Hi, this is our senior project at Cal Poly through the Mechanical Engineering Department, and we designed an optical filter selector. So the need for our project came up because UC Berkeley at their space science laboratory, they needed a way to rotate through 4 different filters, 4 optical filters. This is their current instrumentation, and they can only use 1 filter at a time. So they wanted a way to rotate through 4. They also needed to be able to tilt the filters from 0 to 20 degrees in 0.2 degree steps. They wanted to be thermally stable, robust, so as to protect the expensive equipment below it, and it should use a smart motor, which is what the team is already comfortable with.
When coming up with a design process to fulfill these needs, we ideated and sketched out our ideas, coming up with several different iterations. And then through these ideas, through a decision matrix to come to our selected design concept. This was kind of our ultimate design that fulfilled a couple of requirements, making sure it could fit in a given space, which was an issue for some of the previous iterations, making sure it was made of an aluminum, a requirement from our sponsor, and using screws instead of bolts, and also using a smart motor. And that all came together to come up with the design we ended up using.
So the 4 poles there on the right, that represents the design area constraint that we had to work with. Luckily, we were able to get all our parts manufactured because we outsourced our manufacturing. So that's the picture on the left, shows all our parts machined out of 6061 aluminum. And then the animation on the right is showing how everything is put together, showing that we use screws instead of bolts there. And then we also use something called a smart motor. It's the motor that the team at Berkeley was used to using. So we designed around that. So that's the red motor coming down there, which drives the shaft, which spins the filter wheel. We did some design analysis. We are working with pretty low loads. There's not too much going on there, but we did want to do some analysis on the shaft just in case maybe the filter wheel were to get caught on one of the 4 poles and the shaft were to be under a lot of torque from the motor. Luckily, with a factor of safety of 2, the design is still safe by an order of magnitude. And then with the filter wheel itself, we wanted to see if the thin edges would be any issue from maybe deflection or fracturing. But even with a large load, there wasn't very much deflection.
So we came up with several tests to prove that our design meets the requirements from SSL. Unfortunately, we weren't able to run the life test or the thermal test due to the difficulties of the time. But we were able to put our product together and do a system interface test to make sure that everything fits together and it works out just fine. So overall, our system is able to switch between 4 filters. It's able to achieve the tilting requirements, and it uses the smart motor that Space Sciences Laboratory wanted us to use. Unfortunately, we were not able to run the test to make sure that it is robust and ensure that there's temperature stability.
So obviously we learned a lot throughout this project, but mainly we learned lots of things just being in the situation that everyone's in right now. For the future design, we would recommend designing to just use 1 PRM, since that would significantly cut costs. Obviously, the thermal enclosure needs to be finalized and tested since we were unable to complete that. And then loosening some tolerances during manufacturing would reduce costs. But Berkeley will also be manufacturing this themselves, which would reduce costs a lot as well. Thank you so much for listening.